For starting, just want to understand like what is your level of proficiency in Java? Like maybe that way, that would be better for me to plan it in such a way that so that it can be interactive. So I mean, like, is it like you had programming working experience in Java, and what kind of experience? If you can just brief about that, I can curate the further course accordingly.
So a recent experience is in .NET, Vinay. I'm sorry.
Yeah, I'm Venkatesh. Yeah, I'm Venkatesh.
Venkatesh, sorry.
Yeah, no problem.
So, but I have experience like internship experience like that. I have programming experience in Java also, but it's little bit 2 years back, something like that. But I have an idea. But my recent experience is in .NET.
Okay. Okay. Cool. Yeah. Okay. What about you, Lawrence?
Well, Java has always been my core language.
Okay.
So
Okay.
yeah, so I'm quite familiar with Java.
Okay, that's good then. So then maybe I think since it's core language for you and for Chitra, I think she came from a .NET background. I would try to balance it in such a way that it suits you and at the same time Chitra as well. And it could be I might be sometimes speaking in a more elementary at a basic level for Chitra to bring up to the same speed as you are. Yeah, so maybe that might slow down a bit speed for you, Lawrence. But I think that is just to bring Chitra onto the same speed.
Okay.
Okay. Cool.
Before that, I have one question. Like
Yeah.
the interview will be in, like, for example, if they ask on OOPS concepts, I can explain, right? So is that particular in I have to be in particular in language, or they are particular about concepts?
I'll take the question. They ask you, yes, if you're not sure about if you're familiar with the Java, then only they go to concept threading and all. But otherwise, I have not seen, because I've been in two last interviews, I have not seen any particularly they're enforced you need to answer only in Java. Okay. I have not seen, only people extended saying they bring a topic of threading concept and all, then the topic being extended. But if you're not sure, yes, you need not to talk. They will not go into that level of discussion.
Okay. Yeah.
Okay.
Thank you.
Okay. Hope my screen is visible. Yeah. Lawrence, Chitra, are you able to see
Yeah.
my screen?
Yes.
Yeah. So for this, I think as we know that, the interview is around the corner and we want to just, brush up things, not only brush up, touch base, where are the key concepts. So what I did is I just curated some stuff that is quite important, right? These are like an basic stuff that we need to understand, or, this really helps us to take into the next level of an advanced thing. So what I'm going to cover in this time is, maybe we will also take time into consideration as well, but I would just try to cover these aspects here, like, first the basic introduction of Java and what is about all these things. And then I would touch base on the object oriented concepts. And then I would just go a bit into core features and all this stuff. But at the same time, these are the things that we're going to cover in this session. Yeah. And along with this, what I would try to do is I would just bring up IntelliJ editor, and then I would just run the program to quickly give you a glimpse of, how does they execute, because that is a better way for us to really understand, because just telling it is not going to really help, because when you go to the interview, seeing the program execution would really definitely help you. Okay. Okay, cool. Then I would just jump into basic Java introduction. Hope my screen is visible now. Yeah, right?
Yeah, it's visible. Yep.
Fine. I would switch to. Okay. Yeah, let me start with Java. So basically, I mean, like, before going into Java. So what is your understanding of Java? Maybe Lawrence or Chitra, if you can just, I mean, it's okay. Like, it's not expected to be correct. I mean, because this is just kind of a discussion that we're doing. It's not expected to be correct, but to be interactive, what do you think Java is?
Well, Java is a programming language which is platform independent.
Okay. And what do you mean by programming language? I mean, like, why do we need programming language? Yeah, wild guess is okay.
Well, it's a language that we use to write programs.
Okay, cool. Yeah. Okay, let me just give you a very brief introduction about it. CC. Why we need a programming language is like the way we are communicating now. English is a language between us. You know English and I know English, and then we are communicating with each. Now, when computers work, when you ask a computer to do a calculation, right? The language that it understands is what? Ones and zeros, right? What it does is it just understands only binary, 1 or 0. And as you know, the 1 or 0 is nothing but the voltage, right? The electrical voltage that is happening, right? The thing. So now when it is 1010 binary, so we as a human being, it would be a very cumbersome task to write language in these numbers, right? 1010 to be very tough to write in such language. So this is where programming languages come into picture. So programming languages, what they do is they abstract the complexity, the underlying complexity that exists under an computer or an computer things. So what you do as part of this is I would just write down few stuff here. Yeah. So what programming language? Yeah. What programming language does is whatever it gives you a syntax. Every programming language has a syntax. Likewise, Java also has a syntax. So what is a syntax? A syntax is nothing but a set of rules that tells you have to write a language, you have to write something this way so that the system understands and it converts into an understandable format by the computer. That is 1001, the binary format. So this is a programming language. A programming language is enabling a human being to write a program to ask a computer to do certain instructions, not in computer language, but in a human readable language. So there are many programming languages that have come before it, right? We had Visual Basic, we had C, we had C++ and Java. So why Java now? Why is Java widely used? The basic difference between the programming languages that we spoke till now is like Visual Basic, C, all these things. They are all event-based programming languages. When I say event, means someone clicks a button, something happens in the code. Another click, another thing happens on the code. Now, what Java brings to the table is object-oriented thing. And even it's not Java that brought object-oriented thing to the world. Object-oriented was introduced as part of C++. Okay, so C++ is the one that where first the object-oriented thing has started coming into picture, where Java has took over, and then it started, ruling the world. When I say ruling the world, yes, it's not completely everything is Java, but the most web applications run on this engine called Java. Now, this is just to tell you what is the basics about Java. Okay, any questions till now before I jump or go into the next section?
No.
Okay. Okay, then let me. Fine. Next thing is like, let's go and find out why Java, right? See, the next thing again, as we spoke about, some languages, right? Like, what do you say? Take Visual Basic, okay, or take C. So these languages, or to that matter, C, C++, all these languages, whenever you take a C language, right? And whenever you do something on a C language, so what you're going to do is you're going to write a program that is going to come into like this, right? Now this program has to be executed on that machine that has the C compiler, C interpreter, and it's mostly closely to the assembly language or the machine language that the computer can understand. Now, the only problem is with this is you definitely need to have that particular C compiler running into this. So let's say if this program was written by Lawrence on his machine, now if the same thing has to be executed on my machine or the Chitra's machine, then I have to go and install, put this C compiler and all this stuff. Okay. Now this is where Java comes into picture, and this is what Lawrence you said initially, platform independent, right? So
Yes.
Java is platform independent. So how does it become platform independent? So what is the core feature that makes it platform independent? Any wild guesses like why a Java is platform independent? Based on what?
The virtual machine that converts its bytecode into machine code.
Exactly. So the Java virtual machine. So what this does is the Java virtual machine that we see here is whatever code that you write, right? Like let's say you have written some code. This is a Java code. Every code that you write which has a .java extension becomes a So whatever code that you write here, that becomes a class file. So class file is nothing but the bytecode. I think this term is important because you would be frequently asked about this bytecode terminology. Okay, so the code that you write is understood by the JVM. JVM is nothing but the Java virtual machine. Whenever you install Java, what you do is you install a JDK and a JRE compiler. Okay, JDK and JRE. So when you do installation, what you're going to do is you're going to go to Oracle site. Now Java is open source, so you have to install OpenJDK. This is quite important. Yeah, Java was not licensed till some time. Now Oracle has made it licensed. So there is another thing called OpenJDK that is open source, and whatever Java gives is licensed. Whatever you do, whenever you install Java, what is going to happen is two things are going to come into machine. One is JDK and one is JRE. JDK is nothing but Java Development Kit. JRE is nothing but Java Runtime Environment. Okay. So what they bring is this JDK brings all the executables, whatever that things. I think now it would be too deep to discuss on this, but I would just give you these terminologies that are important when you speak about in the interview. Okay. So a Java installation definitely has a JDK and JRE. The Java virtual machine is built by this JRE. Okay. JRE is nothing but Java runtime environment. It creates a Java runtime execution. So what this JRE does is it creates a stack. It creates a Java runtime environment. Let's say you have a server. So this is your server. When I say server, server can be anything, right? Server can be a client machine or it can be a computer. So in these things, let's say we have a server box, which is a Linux machine, and it has some memory of some, let's say, some 12 GB of RAM. Okay. So we are saying 12 GB of RAM is present on a machine. We install Java in this machine. So when we install Java in this machine, so what is going to happen is you're going to tell that, okay, out of 12G, I'm going to install Java software and give me 4 GB of RAM. So what I'm telling is, okay, from this machine, give me 4 GB of RAM. So when the Java runtime starts a Java process is nothing but just like, in a Windows, when you run a Google Chrome, it's a process. Similarly, when you just run start Java, it is also a similar process in Linux server. It can't be Linux, anything, anywhere you can install Java. I was just giving a basic example of Linux just because, most servers are on the Linux thing. Okay. Sorry. Yeah. And when we say that we're going to give 4 GB of RAM, so what is going to happen is this Java process takes 4 GB of RAM and it creates a Java runtime environment. So this is where the JVM would be, the Java virtual machine would be. And this is what the Java virtual machine that we're speaking about. So whatever this hello world class and all these things that we write would be built, and then whenever it is shipped, when you say it is shipped, you create a jar file. Again, this is another important terminology that you might be frequently hearing about. Jar file. Jar file is nothing but Java archive file. Okay. So what is going to happen is whatever this dot class file, the one that is shipped. So what it's going to do is the JVM can understand that. So now, since you put this Java virtual machine here, and then whatever Java code that you are deploying is directly executed by the JVM. So what JVM does is understands the bytecode, and then that bytecode would be converted into the language that the computer can understand, the machine language. Okay, this is why Java virtual machine is important. Now coming to this question of platform independent. So how is it really platform independent? It is platform independent because now any guy who is having just this JVM virtual machine, they don't need like in a C program, I don't need a specific C compiler and all these things to be installed and run. So it can be like whatever class files, these things, they can embed the JDK within them and they can be executed on a particular machine. And when that machine is executed, the JVM is created on that machine and then you can run it. So this is why we call why Java is platform independent is basically because of this reason that you can write the code once, ship the JDK libraries, everything with it, and you can run on any machine. Just you execute the jar file and then the code is going to be executed. So this is the core reason why Java is platform independent. So remember this term, once written, run everywhere is the core slogan of Java that has been widely used. Okay. Any questions till now before we?
No.
Okay. Chitra, anything from you or?
No, I'm fine.
Okay, cool. Okay then. Next thing what I'm going to cover is about JVM. Yeah, I think what is Java, why Java, Java virtual machine we have covered, and then JDK, JRE we have covered. Okay, let me just get into this object-oriented programming thing. Now, just getting into object-oriented stuff. Okay, so what is really object-oriented is, as I told you guys before, earlier, whenever we click on an event, it is event-based programming. Now, what we are saying is we are gonna do object-oriented, right? In an object-oriented programming language, just a minute, I'll go back to my screen. Okay. Okay. So before getting into this object-oriented programmings and all, let me introduce you to classes and objects. Key entities. I think classes and objects is what you're gonna completely using it in when it comes to Java thing. Everything is classes and objects. Okay. So what are really classes and objects? Okay. Let me give you a very brief example. Let's take a human being, right? So now a basic, when we say human being, we definitely know that guy would have that guy would be a male or female. He would have a gender. That guy would have some height. That guy would have some age, right? That guy would have some complexion, right? Okay. So when we are saying this human, so human being is just nothing but a template, right? Like when we say an animal, there can be different set of animals, but animal is a template. When it comes to our thought process, when we hear about animal, okay, we have some pre-notion things that would run in our mind. Similarly, when we speak about a human being is a template. Now there can be different human beings, and the different human beings are, we know, right? How many people in this world? We have billions of people in this world. So, but they are all instances of a human being. So classes are nothing but a human being. Human being can be a class. So what they tell is a blueprint. So what they say is a class, what it speaks about is a basic anatomy, right? A basic structure of a particular thing. It will not, but it doesn't mean that that is the only way. It can have a different way. Like a human being, there can be different problems. Some human being might have a long hair, some human being will have less hairs and all this, right? So coming to this, class is nothing but a blueprint of a particular structure and all this is. Now, then what is an object? An object is nothing but an instance of a class. Like me, I'm an instance of a human being, right? I would have my own parameters for a human being. Like another guy would be an instance. So this is the core concept of what a class and what an object is. Now, furthermore examples. Let's take vehicle. When we say vehicle, okay, definitely the things that have come into our mind is, okay, it would have an engine, it would have tires, it would have it would have a ability for people to sit and all these things, right? So then these are basic things that you know. So that means you know the template. Now, when I take a Mercedes-Benz car, right? When we speak about a Mercedes is a particular instance of a car, right? Mercedes is a particular instance of a car. So Mercedes can be an object that can bear the properties of a class. Now let me go back and just in Java, how do we build all these things? Is my IntelliJ editor open? You guys are able to view my IntelliJ editor or?
I do use Eclipse.
Okay, it's maybe for this session I would just use IntelliJ, but is my screen visible? Is my IntelliJ screen visible or?
I think it's loading.
Okay. Still no? Wait, let
It
me.
is not shared, I think, Venkatesh. It's showing kind of blank screen.
Okay, now we're just switching
No,
between.
no, yeah, it's coming now.
Fine. Okay. Okay then. Yeah.
I think Venkatesh, we lost your voice.
No, I was just typing. So
Oh, sorry.
yeah.
sorry.
Okay. Okay. Yeah. Just takes a slight time because it will just try to load all the JDK libraries and all. Okay. So this is where you can see what I'm going to write is I'm going to write a Java class. Just a minute. What we do is again I've created a class file here. Everything in Java is going to be a class file. When I say class file, it's a bytecode. bytecode. This is the bytecode that we're going to speak about. Okay. So before getting into this, when we say you can see this class, this is a keyword of Java, and then public. We're going to discuss more about this. These are called identifiers. There are different types of identifiers. When I say public, it is accessible by all. When I say all, it's not like everyone within that project. Okay. Okay. Now, this is a class. Now, what I want to define is like a human being. A human being would have an age, and a human being would have height, and human being would have name, and human being would have a gender. Okay, so you could see that I've named it as int. Int is nothing but integer. Okay, and this I think since you know basic programming things, you would be able to just relate it. Integer is nothing but the amount of bits that are required to store a number. Like if you have a number 20 in binary, how do we write it? It's 1011, right? 10 was it 842116? No, it's 10100. Now that number is total number of bits and bytes. So if you want to store that number, you need to have some uh, predefined things. So int is like it will store 8 bits, and then we have long, it will have store 16 bits like that. So these are like data types, and string is nothing but your names. Whatever names that we have goes into string. Now these are nothing but the properties of a class. So when I say properties of the class, they are like the features of a class. So now this class is a blueprint, and now these are the features, okay? And they are referred as instance variables. This is very important point. Instance variables means instance variables do come when an object is created, but these are the features, okay? Now every class has a constructor. Constructor is nothing but assume that whenever a object is created, the constructor is the one that is gonna first execute. And I would just, as of now, I will just write it, but I'm gonna give you a brief of all these things. Okay, fine. I mean, like I would have written these programs, but the only reason why I want to write it here is so that you also just instead of just bringing the program, I want you guys to follow so that you clearly read this stuff and get things. Okay, so this is a basic constructor. Okay, now next thing, whenever we said class would have again properties and features. It's like a human being. What can a human being do? A human being normally sleeps, right? So this is nothing but a method in a class. Okay, right? So again, what other things can human being do? Human being can eat. Okay. So as of now, just we'll go with these two things. We don't, there could be many things, but just since we're just discussing the very basic thing. So these are called methods of a class, and these are the properties of a class. So we have seen a class is a basic blueprint. So what it says is human being as a class has these properties, and this guy can sleep and eat. Now come the next thing, the object. So what we said about object, an object is an instance of a class, right? So how an instance is created. Okay. So again, whenever we are creating one thing, you guys have to see, whenever we create a class, the whatever file name we give would be the same name as the class name. That is mandatory, because even if you try to change it, it's going to throw you an error. See, it is mandatory. Okay. Now, this is important. Pay attention here, please. Every Java program needs a main method. Without a main method, the Java program doesn't execute. Yes, there could be Java programs that could be executed that you might not be knowing it, but underlyingly there would be a main method. Whenever the Java runtime environment is asked to execute a program, the first thing that it will look is this main program. This is the entry point that it will come and it will start the execution. It will not just go randomly anywhere. The main is the first thing that is going to be important. Now, why would I have written this big string of public, static, void, main, and strings? Public, as I told you, there are different identifiers in Java. Okay, the identifiers are, I would just write here. I would not go to the other one. Public, private, and protected. There is something as default. We will not discuss it. That's too advanced. So what is public? Public is something that is accessible to everyone in a package. Like here, if you see, my project is this. So this one project, if you see, there is a source here. Source is a package. I can have different packages in a project. So what are packages? Let's take a web application. Let's take an e-commerce application. Whenever we have an e-commerce application, there is one section where you can order things. One section where you have to pay for things. There is another section where you can claim for refunds, where you can claim for support. Now, ordering, billing, support, these payments, if there are 4 different things in an application, these 4 can be 4 packages in a Java project. There can be categorized as 4 packages. So each package, this public is like each package in this project can access this public. This is accessible. Now, when we say private, it is only accessible to the object of that class. That means, don't get into the deep things. I will just say basically what private is, it is restricted. So if you have to access this private variable, you need a special privilege within the class, the object of a particular class, to access it. And there is another thing is called as protected. With this protected, it is slightly reduced in terms of a private. But these are the basic access modifiers in Java: public, private, protected. And mostly you would be touch based on this particular thing, asking like, whenever they could ask like, if I have some variables and if I want my variables to be restricted, I don't want those variables to be executed or accessed by people outside my package. If someone say I want a restricted access to variables, your immediate answer is private access modifier. Okay. Now coming back to here. So what I'm telling this is, when I say public, I'm telling that in this package or in this project, let this be executed by, accessed by anyone in this project. When I say anyone in this project, so that it can. Static, I would just go, when I go into this thing, I would just clear this particular thing. But as of now, it would be heavy to tell you guys. I would keep it. And the other thing is void. Void is nothing but a return type. Okay, when I say return type, what is like, anytime you execute a method, if you see, there is a human being class here. Everywhere I have given void sleep and void eat. So what I'm telling is, when this method is getting executed, I am not going to return anything. That means I'm not going to return any variable. Let me just tell you clearly here what is going to happen. If I say I would return an int, I'm telling this I will return an integer. Okay. And I didn't write anything. So what did it tell here? It threw me an error here. So it says missing return statement, because I told that I'm going to return an integer variable, but I'm not returning. If not integer, I will tell, okay, I'm going to return a string, but I don't return anything here. And it throws an error saying that you told that you would return something, but you're not returning. And the one way to fix this is telling return something X, and then see, it compiles. So this is what a difference of void is. So when I say void, it clearly says I'm not going to return anything. So it doesn't ask me as well. Okay. This is important, guys. So Lawrence, Sachitra, any questions on this particular thing? Return type. So return type is like, yeah, whenever you execute.
No.
Okay. Yeah. Okay. Fine. Now, when I'm saying, when I execute a main method in Java, and a main method in Java, I'm not going to return anything. So you can safely execute it. So that means whoever is calling this method in this Java and runtime environment, they can safely execute it. They're not expected to, this is not expected to write in a return statement. Okay. And string of args. So whenever I say this, string of means array. So whenever you execute a main method, right? Let's do in an e-commerce application, you're ordering something. you're going to have some input, right? You're going to give some input. So that is why you need these arguments here. So these arguments are nothing but you are passing some inputs for the program to execute. Okay. Now, so what's going to happen is we are saying this program is going to get executed. So now what I will do is I would create an object of a class. Okay. So human being is nothing but a class. Now there will be an object for this class. So how we create an object is we say human being Adam is equal to new human being. Okay. Okay. It throws an error. Okay. First, let me tell you a few things here before fixing that error. New is the way to create an instance of a class. It's important again. Whenever we say new, we would be asked questions like, how do you create an object? We just say new.
48% of Americans have nothing invested in this.
Okay. Yeah. Fine. So whenever we say new is nothing but the way we create an instance. Okay. So you could see there was an error here. So what it is telling is, I told this particular programming language that whenever I'm creating an human being, whenever a human being is born, there could be some parameters for him and we need to define those parameters. So that is why it says here I'm not giving them. So let's say when I write Adam, I'm going to give his age as some 30. I'm going to give his height as some 162 centimeters. And I'm going to, this other parameter, I'm going to give his name as Adam. And I'm going to give his gender as male. Okay. See? So this way I've created an Adam object. So this guy is an instance of a class. Now this guy can do whatever a class can do, right? So this guy can sleep and this guy can eat. So these are the methods. So anything with this brackets and then this curly brackets is a method. This is also a method, but this is a constructor. I would introduce you guys to constructor sooner, but as of now, just remember that this is a constructor. But take these things into consideration. Every Java class will have methods defined. The blueprint says that whatever I can do, I can run. Human being can run. Run is a method. Human being can work. Work is a method. And it defines how can he run. So what is defined in a method is, if I say human being can run, how can he run with his legs and all these things? These are all instances. They are all particular properties. Okay. So this is the way of object creation. Now Adam is an object of human being thing class. Now we can see Adam dot sleep, Adam dot eat. Okay. And I'll show you another thing here. I said that we need a main program to execute. Without that, it won't be executed. If I run this, I don't get even a ability anywhere here. I would just, you would understand the difference here. When I click here, you can see it asks me to run this, run human instance dot main, debug and run. But you would never see here when I do this. So this is very important. You need a main program for a program to be executed. Now, when I run this, initially it would take slight few seconds of time because it has to build and all, but once it starts builds into the cache, it would automatically run faster. Okay. You can see here it is parsing and then it is putting into cache and all these things. So you can see the methods are executed. So understand here, I created an object and I told Adam dot sleep. See, I'm executing this method. So it is not the class that is executing. Class just created this blueprint and it has kept everything there. An object is executing this. So Adam as an object is executing this sleep. Adam as an object is eating. Adam as an object is sleeping. So that is why they're saying human being is sleeping, human being is eating. Now I will just give you another object. So as we told that, right? Human beings, there could be billions of human beings, instances of human beings, right? So this is where you create one class and multiple objects. right? And I say 26, 156, Eve, female, and slight introduction, every Java thing that has to complete with this stroke, right? Without that, it would be an error. Now I created a Eve object. So you can see, right, how many objects I've created for one class? 2. I'm not going to stop here. I can create any number of instances. Okay, and this is the beauty of object-oriented programming language. This is where Java as object-oriented language or C++ as an object-oriented language has brought this world so much of ease in developing things. So I can say Eve dot sleep, Eve dot eat. I would just execute it. Okay, you see this 4 times. Now you might get a doubt that, okay, like I created 2 objects, but then it's saying human being sleeping, human being eating. How do I understand? So this is where the instance variables. Every class is having, I told you, these properties, right? And then this, whenever I create an object, this class will assign these properties to that object. So this is how I would show you that. Name. Okay. Now when I execute this, see, Adam. Wait, I'm gonna. Okay. See, did it? It didn't save, but okay. What it says is Adam, human being is sleeping. Adam, human being is eating. Eve and all. So if you see here, this is the first method that got executed. That's why it says Adam. And the second method, Adam. So you can see there is a single object or single method, but different objects. So this is the basic understanding of classes and objects, methods and instance variables. Again, I'm reiterating, a class is a blueprint. Like a human being, he's just a class. He defines properties. He defines properties of a particular entity. Like a human being, these properties are defined, and he defines what that things can do. So class is just like a main blueprint that it defines certain traits or characteristics. Now object, this is object. An object can be created using a new keyword. This is a new keyword. Anything that you see that changes color is a keyword. Means Java programming language has some keywords. When I say what are keywords, keywords means they are particularly used by the Java programming language compiler. You cannot reuse those keywords and write, like here I have written human being Adam and human being Evan, right? I cannot write public like here. If I write public, it will throw an error saying that you're using a keyword. These keywords are reserved. Okay, they are not being used by programmers. They are reserved. So this is an object. An object is created using a new keyword. So an object can execute an object inhibits the properties of a class. Okay, and this is another object. And instance variables, these are called instance variables. Means every class will have instances. Like I have my own instances with these characteristics. Like you guys will have your own age, your own height, your own name, your own gender. Like these are your instance characteristics. Okay, and the other thing is methods. Every class has methods. Methods are nothing but the behavior. If I put a vehicle class here, what I'm going to write here, I'm going to write like in tires, engine, and I will say that public void drive, public void rest, public void brake for vehicle class. And this entire world is nothing but classes and objects. This is all about classes and objects. Any questions, anything you want me to reiterate?
No
No,
question.
Venkatesh. No questions.
Fine, okay. Now let me go back to my board. Okay. I've covered classes, objects, methods, instance variables, and then okay. Now I will cover about inheritance. I would stay on this Eclipse editor because programming it would be easy for you to show things. Fine. Next, let's speak about inheritance. Any basic idea inheritance about Lawrence? I think you.
Yes. So this is when one class, a child class, inherits all the properties of another class, the parent class.
Okay. Okay. Good. Yeah. So inheritance is nothing but what we inherit from our parents, right? It's as similar to it. We inherit traits from our parents. We inherit money, all these things from our parents and all those things. This concept is quite similar to that as well. Okay. So basically, we have two different things in inheritance. Okay. We call superclass, parent class, and the subclass. Okay. Uh, let me bring. Okay. Fine. Okay. Fine then. So inheritance is nothing but what we are saying is we and then okay. So this is nothing but a I would say parent class, and this is nothing but a child class. And okay, whenever we say a parent class, I have written it as parent, but it should be parent class. Whenever I written child, it should be a child class. As we already spoke about, right? Class is nothing but a human being having different set of traits and behaviors and characteristics. So let's take the same concept and apply to a parent and a child. Okay. Now, when a human being like this object, the Adam object that I've created, he is an object. Now that Adam has a particular traits. Okay. Now Adam as a guy can be an individual who can do some set of specific activity. Maybe Adam can be a hunter who can hunt food and all this stuff, right? Now he is a parent. Now coming to his child of Adam would inherit all the properties that Adam would get. Maybe they could be different. They could be different. Like child of Adam can inherit his hunter capability because parent has that hunter capability. Child of Adam can also acquire or inherit that hunting capability. So in this case, in Java, coming to programming concepts, what we say about inheritance is nothing but whatever a parent class has, the child guy can inherit them. And it's not that the child class can only have hunter. He can acquire this hunter thing, but still he can do some other stuff. He can surf. He can be an ocean guy. He can be anything. But he acquires the parent thing and he would do few more things. So the advantage of this is, let's take a basic vehicle class. Okay. When we say vehicle, a normal vehicle, what we're saying is we would say a normal vehicle should have like an engine, should have four tires. We say it should have braking capability, it should have the guy to able to drive, it should have a steering and all these things. So a vehicle, these characteristics we have defined. Now, as we spoke earlier, Mercedes can be a subclass of a vehicle or a car. So car is a subclass of vehicle. So what car can acquire from vehicle is driving capability, tires, and all these things. But car has its own special properties that it can have only four tires, right? Maybe like the other heavy truck vehicles can have eight vehicles, right? But these guys have acquired it everything from a vehicle class, but they have their own properties. So that is why parent can have properties and child can acquire them, but child can have even more than the parent. This I would just show it in a programming terminology. Okay, I would just write a basic class. Is my IntelliJ editor visible to you guys or?
Not yet.
Okay, I think the switching is taking a bit time. I should share my desktop. Yeah, that would be better. Okay, what I'm gonna do is I'm gonna write a vehicle class here. Okay, so when I write a vehicle class, I'm gonna give properties like int. What do you say? It's gonna have an engine capability, right? And then what I'm gonna do is int. I'm gonna say that tires. I'm gonna say that int. What else can a vehicle? It has an engine capability. It can have a power capability. The tries can think of a vehicle. Brakes. Okay, fine. Again, I'm gonna write an constructor here. Whenever I write a constructor, I need to give the data type as well. I'm gonna add one thing here. I'm gonna name the name of the vehicle. Okay, fine. So I just give this properties for this vehicle. Okay, and this is the class. And then what I'm telling this vehicle can do is public void new. This can drive on road. Okay, fine. This is the first basic thing that we are given. Now, what I'm going to do is I want a basic car to be built out of this vehicle thing. So I'm at a car class. Okay. And what I would say is extends vehicle. I'll tell you why I have written such a default class, but yeah. So what I said here, extends. Again, extends is a keyword. So this says this car can extend vehicle. So it acquires all the properties that a vehicle has, and it can have its own thing. So car can have its own airbags, right? Its own music box, maybe. These are particular additional things that this car can have, and this car particularly can have a specific method for itself. Liquid. Yeah. What a particular car can do. Drive in narrow roads. What I'm just telling is that this car can drive in particular narrow roads. Okay. So this has extended these things now, and then it has its own additional method here. Okay. Fine. Now what I'm going to do is maybe I would just create an instance of this classes. Like you would again, I would write a public static void main, as I told you guys that this is important to execute a program. Without this, I think the Java program would not get executed. Okay. Now what I'm going to do is I will say car. This is new car. Okay. And it is that if you see here, what it brings is, see, it gives me brakes, it gives me engine, it gives me music box, it gives me drive, and it gives me a method drive in narrow roads. Okay. Now, did I define this brakes engine to this car? No. I just, the properties that are defined for this class is just airbags and music box. But how did it get these things? It got it from vehicle, because vehicle is the superclass. Vehicle is the parent. It acquired from the parent. By default, it acquired them. I didn't specifically tell it. And it has its own additional features here, drive in narrow roads. Okay. So this, if you see, it is not present in for a vehicle. So that you would clearly see here. Let's say if I create a okay, if I create a vehicle class, I would say vehicle as some, some truck, and say vehicle here, and I say truck dot. See, it doesn't get the properties that a car has. It only shows me tires, brakes, engine, name, and drive method. But a car shows me additional methods as well. They are drive in narrow roads also. So understand, this is the basic difference between a parent class and a subclass. And this is all what inheritance is all about. Inheritance is a subclass. A child class can acquire the properties of a parent irrespective of whether the methods or the variables are defined in that class or not. It automatically acquires them. And one important question that we're going to ask in interview is, what is the superclass? What is the parent class of all the objects in Java? It is object class. Okay. So this object class, you need not specifically say this object, what I showed to you guys, this object dot. If you see this object dot class, this object class is the higher level parent class for, if you see here, object is the root of class hierarchy. Every class has object as superclass. Just remember this. This is frequently asked. They would be asking it. Most of the interviews, they stress on this point. What is the superclass of any class in Java? Object class is the superclass. Okay. So this is all about inheritance. So any questions on inheritance, Lawrence?
No.
No, Venkatesh. No.
Okay. So is it okay that the speed and is everything fine, or you want me to trim down, or you want me to touch base anything? Is the
I'm
speed
fine.
okay? Okay. Fine. Okay. Okay, then the next thing what I'm going to discuss is, we spoke about inheritance, and another thing within inheritance what I'm going to tell is, yes, and it's not only the car, right? Not only one object can extend. There can be many classes that can extend. Like here, if I take this out, okay, I'm going to create a new one. Let me say, what is this vehicle? I'll say motorbike. Motorbike is again a vehicle, right? And then motorbike would have, int gears. Motorbike will have a gear, right? And then motorbike would have specifically int handle, or we would uh, I would confine it to in gears here. And then for motorbike, I'll have an other public void okay. Okay, fine. So now even this motorbike can extend vehicle. Okay. Sorry. Yeah. This can extend a vehicle. Now this motorbike is another. So likewise, there can be, many childs to a parent, right? In a normal human terminology as well. Like there can be many childs to a parent. It's not that only one child for a parent, right? So similarly, if we create a motorbike again, this motorbike also extends this. But one difference is it cannot, this is not supported in Java. This is not supported in Java. This is supported in other programming languages like C++ and all these things. This is again important. Multiple inheritance is not supported in Java. Okay. Multi-level is only supported. That means a human being, a child cannot have two parents. That is supported in C++ in other object-oriented programming languages. But in Java, a child can have only one parent. It immediately throws you an error. It clearly says here, class cannot extend multiple classes. And this could be again asked to you guys that is it really in Java, not supported in Java? Yes, it is not only supported in Java, but it is supported in C++ and other things. Okay. Similarly, again, if I create an instance for this motorbike, again, you have to again remember this, that motorbike, whenever I create a bike and all these things, I'm going to use a new keyword. New keyword is used to create an object. Any class will have an object and new would be used to create an object. So if I create a bike object here and I play with that bike object, see, I get the brakes, I get the engine, I get the gears, I get the name, and I get an additional method called racing bike here. Okay. So this is only for me. But if the same thing is created for vehicle again, parent will not have this. Yeah. Truck dot. See, racing bike. Whatever is given for child is only for the child. Parent will not have access, but the child can access parent. So this covers the multiple inheritance part. So clear point. Again, I'm reiterating, Java doesn't support multiple inheritance. It only supports multi-level inheritance. You can extend only one class. And this is only in Java, but in other programming languages, yes, multiple inheritance is supported. Okay, fine. That with that, let us go into next thing. This is polymorphism. So polymorphism is nothing but taking more than one form. Polymorphism is let's take a simple example. Whenever you use a browser, right? You use a browser to enter some URL and all these things. Whenever you enter a browser, what it happens is it goes to a server. There will be many things in the middle. I'm just generalizing for you guys a simple example. The expectation is it goes to a server and that server will give you data. Now this server is what? It is providing you the data. There could be instances like that you enter a shopping site, but that the product is present in another shopping site, and this shopping site is kind of helping you to gather products from different shopping sites. Now in this case, when you hit the first shopping site in your browser, the first one that you're gonna enter is will give you data, but it is asking another site to provide the data. So here, this particular shopping site server that you're first entering or hitting, that is taking two forms. One, it is giving you the response. The other part, it is asking someone to give the response also. So the one single guy is doing multiple jobs here. So this is nothing but this is the basic concept of polymorphism. One object or one particular activity doing multiple things. So I will just give a basic understanding in polymorphism. Okay. I will just take this. In basic polymorphism, we have two things that are important to us. So one is overriding. I will just write it here. The other one is overloading. Okay. And these are again important terms here. When people ask you about polymorphism, again, this is an OOPS concept: overriding and overloading. So what is the difference between overriding and what is the difference between overloading? If you have a method like this, public, I would just write a real class here. It would be easy for us. Like let's say there is a sleep method here. Okay. Now I'm gonna write another sleep. Okay. And then I would say okay. See, it is the same method as the old one, but if you see, I just added a new one. So this is overriding. So I'm just using the same method, but I'm bit changing it. When I execute this in a human instance class, and I say this, definitely the object name is E, but I will just overwrite with and when I execute this, okay, see, you can see this Eve is sleeping. That is a regular method. Okay, and there is another method here. Eve is sleeping in another method. So there, what I've done is I have added Adam instead of Eve. So when I've executed it, see, I just passed this Adam. So what I've done is it is the same method. I mean, like normal programming languages, whenever you have done any programming, they don't allow this kind of thing. And this is what object oriented allows you. So you can have the same method, but with different parameters. What you're simply doing is you are just overriding things. Then what is overloading? Okay. Overloading is nothing but you would have the same method. You would have the same method again, but it would be present in a different manner. So like this, when you have this human being and human instance, okay. Let me create a class. And this class is man class. And this guy extends human being. See, so extends is I'm just saying that I'm the child of this guy, human being, parent. Okay. So this guy has, now what I'll do is I will just add one additional parameter for this guy, int work. Maybe man is someone who's gonna work, and here I'm gonna write another one, public void okay. Now a couple of concepts here I'm gonna touch here. See name. I just directly gave the name variable here, but did it complain? No. Why it didn't complain? Because it is telling me, yes, you are extending, you are child of human being, and whatever properties human being has, you also get it. So that is why you got the name here. So human being name. So it didn't complain. If I do not extend this, let's see if I remove this, and see, it is complaining here. It is saying I cannot resolve this symbol. Now, this is what the Java compiler and all these things are doing in the background. So if I extend it, it is automatically taking it. If I don't extend it, it is complaining me because it is inheriting the properties of the parent class. And you can see I have written the same method here, right? Now in human instance, how do I create a variable is man is equal to new man, right? And Adam man dot sleep. Okay. Now there are two methods here. So one, Adam is an object, Eve is another object. Now I have another, this is a man class, and then I have Adam man, and I'm saying Adam man dot sleep. And when I execute it based on the output, I will run you through what happens in this output. See, fine. Ignore this null is in main class and all. My intention is not to just clearly show the data. That's why it's okay. But if it is fair, I would give the name class. So what it is telling me here is I just gave it as a sleep here. And even I gave it as Adam dot sleep here. But what it is doing now, it is executing based on the different context of it. So though it is the same method, it is overloading it. I didn't, in overriding, I changed the parameters. But in overloading, I didn't change the parameters. It is the same parameters. Now you will really understand the difference in this class now. So if I create a human being class, not as an Adam, when I create a human being, I wouldn't say human being. What I would say is man. Man 1 is equal to new human being. Okay. So I'm creating an instance of this man class here. No, I think I went bad. No, this is not right. I'm sorry, I overlooked it. Yeah, this is the exact thing. So man, new man, whenever created, and then I was just saying this sleep method. So overloading is having the same method and with the same parameters. Overriding is having the same method name but with different parameters. So what it is doing is, this is like when I said initially, when I said it about polymorphism, single object or single thing taking more than one form. So here in this case, though sleep is a single method, I mean, in terms of a name, but it has more forms. One with this, I can have another one here. I can simply say public void sleep int age, and I can write here. So did it complain? It never, and it won't. This is what it is allowed here. I can override it, but the parameters have to be different. Now the question comes when I give the same thing. If I give the same thing, now this is when the question starts coming in. This is when it cannot resolve. It is already saying it. But this is what is supported in overloading. That is in another class. Not in this, like here. Here I can write. Here I can put string name, and it doesn't complain. You guys got the difference between overriding and overloading. So overriding is having the same name, but with different parameters. Overloading is having the same name, yes, but in a different instance or in a different object. This is the core difference between overriding and overloading. And this is what is frequently touched whenever an object-oriented concept is being asked. When they ask you to define polymorphism, this is what you're going to say. Polymorphism is all about taking more than one form. And when we say more than one form, it is in two different ways. One is overriding, the other one is overloading. Overriding is same method name, but different parameters. Overloading is same method name, but in different instances of the class. So do you guys need a slight break of 5 minutes or?
Venkatesh, I'm just thinking, is hoops is done, yes? Kind of.
Almost just 4 are pending, abstraction, encapsulation, and interface packages pending, Vinay.
Okay. I think they also already had one session, Venki, about
okay. Yeah.
this. Okay, what we do is we'll wind up here. Okay. So Lawrence, you have any particular questions or Chaitra about Java in particular? Because I know you already had lengthy session at DS. It could be more for you now if you continue. If you have any questions, other leave this one. Any general questions you have, we'll try to address it. Okay.
Yeah, I don't have any questions. I'm just looking forward to multi-threading. I think that's where
okay, multi-threading.
Yeah.
Okay. Chaitra, you have anything?
I don't have any questions, but in regarding to interview, what are all the things we need to be prepared, like like programming level or like
they don't ask you to write anything as because we could have explained you here just like a layman English terms, but he has gone to the coding because to make you perfect. As you understood the concept here, what he has explained is more than enough to explain tomorrow into. No one is asking to write the code, but sometimes it may ask you to write a code in any of your known languages for puzzle solving. That is pattern printing, I showed you earlier, or matrix. They may ask you it any of the known language. You need not to pick Java or anything, but someday may ask you to pick any of your programming language. Try to write, do that.
Okay.
Okay, but conceptually you should know what is he's explained the hoops concept. That should be good. Okay. Venkatesh, what we can do is we'll take a break 5 minutes, then we'll come back, or we'll finish the threading and we'll wind up. Up to you, Venkatesh.
Lawrence and Chitra, because multi-threading, I feel you need to start fresh, because if you're completely down, because it's a complex topic. Yeah.
So,
I think I have some other work.
Yeah, you can drop it, Chaitra. You can drop it. Yeah, and all the best for tomorrow's interview. Yeah.
Okay. Yeah. Thank you. Yeah.
Lawrence, what we do is we like to continue, or because
we can continue.
You take maybe Venkatesh, what we do is let me stop and start break only
this part I have stopped here.